What's up, Gen Z future CPAs, and welcome to this explainer. Today, we're literally hacking your brain to help you encode linear programming formulation for your Management Advisory Services exam. Look, we all know the licensure examination for certified public accountants in the Philippines is a massive hurdle. And if you're in your second or third year right now, you absolutely need this information to stick in your long-term memory for the next 3 years. So we're totally ditching the boring traditional lecture style. Instead, we're focusing on how your brain actually works, so you can analyze better and retain this knowledge way longer. Here is your LSCPA battle plan. 1. Brain hacks and LP. 2. Relevant costing versus LP. 3. Decision variables. 4. Objective function. 5. The constraints. And 6. A rapid bullet review. Let's get into it. All right, starting off with section 1, brain hacks and the LCPA. So, you might be wondering, why this stark white backgrounds? Well, this is a deliberate study hack called clean slate encoding. By stripping away all that useless visual noise, the complex graphics and unnecessary textbook screenshots, we're actually lowering your cognitive load. Your working memory has a limited capacity. We want 100% of your brain's RAM focused entirely on these core accounting equations, so you're not wasting any of your precious cognitive energy. Moving right along to section 2, relevant costing versus LP. Now, you likely already know relevant costing, right? It's fantastic when a factory has just a single bottleneck. Like, imagine you have just one stitching machine that can't keep up. In that scenario, it's easy. You simply prioritize the product with the highest contribution margin per unit of that one limited resource. But what happens when reality hits? What happens when you're short on machine hours and labor hours and raw materials, literally all at the same time? Well, that is exactly where linear programming comes in. It's this incredibly powerful quantitative technique you use to handle multiple overlapping resource constraints to ultimately optimize your business objective. I know formulation sounds kind of intimidating, but it's really just the process of translating messy, real-world verbal descriptions into clean mathematical models, and it always follows these 4 predictable steps. Identify decision variables, write the objective function, formulate constraint functions, and finally, assume non-negativity. Honestly, once you memorize this 4-step sequence, any LP problem on the MAS exam basically becomes a simple fill-in-the-blank exercise. Okay, section 3, step 1, decision variables. Every single linear programming problem starts by figuring out what you actually have the power to change. Decision variables are exactly that, the choices available to the decision maker. In a manufacturing context, this almost always represents the physical quantities of the products you're deciding to produce. Because think about it, you can't optimize a production line if you don't mathematically define what's actually coming off that line. Let's ground this with a real example derived right from the RISA CPA review materials. Looking at this data for the strawberry company, we've got 2 models, small and large. So the crucial first step is defining our decision variables. Let's call the number of small models to be produced X and the number of large models to be produced Y. Boom. X and Y are now our decision variables. Keep this table in your mind, because we're going to use it for the rest of the explainer. Next up, section 4, step 2, objective function. The objective function is absolutely the heartbeat of your linear programming model. It's a mathematical expression that specifically maximizes or minimizes some quantity. As a future CPA, you're usually going to be looking at maximizing your total contribution margin or minimizing your total costs. Without an objective function, your math is just floating around with no actual direction. So going back to our strawberry company data, remember that the contribution margins are 5 pesos for the small model, which is X, and 7 pesos for the large model, which is Y. Therefore, our objective function is simply maximize Z equals 5X plus 7Y. Here, Z represents our total profit. Every single unit of X we make adds 5 pesos to Z, and every unit of Y adds 7 pesos. It's clean, it's highly logical, and it's exactly what the examiners want to see. Section 5, step 3, the constraints. Now, in a perfect world, we just produce infinite quantities of X and Y to make infinite profit, right? But in actual business, you never have infinite machinery or raw materials or labor. Constraints are linear inequality relationships that represent these harsh real-world realities. They represent the maximum availability of scarce resources that physically limit just how much a manager can actually pursue that objective function we just created. And this brilliantly illustrates how we turn words into math. From our strawberry company data, the small model X needs 2 machining hours and the large model Y needs 4. But the factory only has 100 machining hours available in total. So our machining constraint equation is 2X plus 4Y is less than or equal to 100. Similarly, for the polishing department, X takes 1 hour and Y takes 3, with only 90 hours available total. So our polishing constraint is 1X plus 3Y is less than or equal to 90. See, you just add up the time consumed by each variable and cap it at the maximum limit. Oh, and never, ever forget the fourth step, the implicit non-negativity constraint. Even if a test problem doesn't state it outright, it is always assumed. Mathematically, sure, lines on a graph can go into negative numbers forever, but in reality, you obviously can't manufacture -5 units of a small model. So we formally state that X must be greater than or equal to 0, and Y must be greater than or equal to 0. All right, bring it home with Section 6, Rapid Bullet Review. I want you to take a mental screenshot of what's on screen right now. These bullet points directly reflect how these concepts are tested in your MAS review materials, drawing straight from MAS 9707 and RESA concepts. Let's recap. LP optimizes an objective function subject to multiple constraints. An equation like maximize z equals 5x plus 10y, that's your objective function. The term constraints always flags scarce resources, and we express them as inequalities, like less than or equal to. And finally, non-negativity is always assumed. Read these over, maybe close your eyes, and try to repeat them back to yourself. That active recall is exactly what guarantees that 3-year retention. So let me leave you with this final thought. As a future CPA stepping into the business world, how will you use linear programming to uncover hidden profit potential when a company's resources seem impossibly tight? Because by mastering formulation today, you aren't just solving a math problem for a test. You are literally building the ultimate optimization engine for your future business clients. Keep grinding, keep that cognitive low, and I will see you in the next explainer.